at this point, it's a good time to summarize our quantum numbers that we have that are associated with these wave functions. So we have the quantum number n that's associated with the radial part, and this is known as the principal quantum number. And this quantum number is what tells us the energy of our system, right? So we saw that in our energy expression that we just saw, n is the only quantum number that shows up. So L and m sub L do not tell us anything about the energy of the system. And what I'll say is that's the first approximation. You may know from the periodic table and what you learned in freshman chemistry that in general we think of s orbitals as being lower energy than p orbitals, and that's true when you have more than one electron present. But when there's only one electron present in the hydrogen atom, they're actually equivalent energies, the s and p orbitals. Okay, but the principal quantum number tells us energy and also tells us the, as we'll see in just a minute in a few videos, size of the orbitals, right? So as n gets bigger, the electron gets further away on average from the nucleus. All right, then we have L, known as the angular momentum quantum number. And we saw that this is directly related to the angular momentum of the system. So that's where the name comes from, right? And so L will tell us the angular momentum. So L, I should say, is directly related to L squared. And it also tells us the shape of the orbitals. All right. And then we have the M, or sometimes it's written as m sub L, which is known as the magnetic quantum number. And this is due to the fact that orbitals with different m sub L values behave differently in under a magnetic field. So the energies split under a magnetic field. All right, and what m sub L tells us about the orbitals, they give us, what's the value of Lz, and what that tells us is the orientation of the orbitals, which way the orbitals point. Now, again, just to put all together in one place the rules about the how these quantum numbers depend on each other. So n starts at 1, increases by integers up to, in theory, infinity. L can range from 0, increases by integers up to n minus 1. And m sub L goes from negative L plus 1, to 0, to L minus 1, to L plus 1. No, sorry, no plus 1 there, just to L. Right, so it goes from negative L to positive L. All right, and so that's the summary of the quantum numbers that we have that describe the hydrogen atom. And as you know, these also are, we still use these even when we get beyond the hydrogen atom to describe multi-electron atoms.